Hey guys, been about 3 weeks since I put up a video. I'd like to do better and, try to get one up every week, but just have a lot of things going on in my life right now. Haven't had time to do videos, but I do have subjects I want to cover, so hang with me there and try to get some more videos up here, in the coming weeks. But what I want to talk about here is this Shure Electronics Class D stereo amplifier kit. It uses the Texas Instruments TPA 3122 IC right there. And notice it's kind of spread out, and that's because it's a kit. You actually solder it all together. I got this at Parts Express. Now it's 20 bucks. But they usually have it on sale for 15 every so often. You probably find it elsewhere. All the components come in this handy little case with these adjustable dividers that you can move around. I guess them are fixed, but yeah, that's kind of nice. I can use this for other things. And here's the board. It doesn't come with any instructions, but the components are silk screened right on the board, what value and all that is, polarity, so no problem there. Has RCA inputs, does come with a cord that has a stereo mini jack on the other end, so you can hook up your iPod or Walkman or whatever. It has this adjustable gain level here, so depending on your source you can adjust that to whatever level you're using. There's the Telltale Class D LC filter on the output. And they don't give you a power supply. It runs from 10 to 30 volts. They did have a diode here in series with the power supply, so you don't damage it if you hook up inverted supply voltage. Little power supply LED indicator there. One kind of annoying thing is it has, on the output here, it has holes for binding posts, but they don't give you any. And they have holes for this connector here, and they don't give you that either, so you're going to have to solder wires or do something to connect to your output. So it's a pretty simple kit. It wasn't very difficult to assemble at all. But right now I'm going to hook it up and do a power output test and a sound test, and there are some issues with this board I want to cover as well. So be right back. Okay, have the amplifier powered up. I have my Walkman music player connected to the inputs, but it's not turned on yet. And I have non-inductive loads, 4 ohm loads, connected to both outputs. We'll do a power test here in a minute. Oscilloscope is connected at the point of the load, so there might be some voltage drop from my connections here. I'm just using alligator clips. Even with no signal on the output, or no audio signal, I'm getting a 240, it's jumping around a bit, 245 kilohertz signal at around 685 or so volts RMS. Well, being Class D, that's its switching frequency, and some of that is getting through the filters. I don't think that would matter much with the ordinary speaker because, for one, it's order of magnitude beyond hearing, and the inductance of a normal speaker voice coil would, it wouldn't conduct much of that energy anyway. So okay, before I do the test, I did notice one issue. When I'm powered up at 14.5 volts, and it's drawing 128 milliamps from the power supply. That's almost 2 watts, just shy of 2 watts. What's going on here? Even if I take the loads off the output, it still draws that extra current. And that's about twice as much as even an analog IC type amplifier. Why is it drawing so much power at idle? Well, if I feel around here, I should feel something getting pretty warm, because you know that power has to be dissipated somewhere. You know, the chip is a little warm, not much. The capacitors, a little bit of warmth to them. I mean, just barely. But these coils, they are pretty warm. Well, what's happening is, I guess the ferrite they use, or the ferrite they used in these cores, are not fine enough grain, and there's some eddy currents flowing, generating heat. Because like I said, even if I take the loads off, these are still getting warm, and it's still drawing all that extra power. So that's not really you know, the fault of the IC. It's just the filtering they use. They have to do something about that. You know, it's Class D. I'd expect it to be more efficient, you know, especially if you want to use batteries with this and it's drawing that much power, and you'll be disappointed in your battery life there. Well, that's one problem with this chip. Let's go ahead and do a power test. Okay, the power test, just testing at 1 kilohertz. And there's the waveform. And if I turn it up, it's, you know, starting to clip. And right here, as high as I can set it. Like I always say, the steps of the volume control are not fine enough to really tune it in there to the before clipping part, but yeah, that's close enough. We'll just run with that. Now that is a big fat waveform, because again the switching frequency is kind of riding on that sine wave there, and I had to mess around with the triggering to get that stable, because it was causing it to jitter around. So if I do the math, you know, we're getting 3.67 volts. And that ends up being about 3.4 watts. Yeah, not too bad. I'll say, you know, if I had a finer volume control on this thing, I'd probably get it around 3.5 watts of clean power before clipping into 4 ohm loads, both channels driven with this little board here. Yeah, that's not too bad. And again, if you crank up the power, you know, you can, you know, I'd go up to, I wouldn't go any higher than 28 volts, but you can certainly run it at 24 volts and get a lot more power out of this thing. However, that brings up another problem with this amplifier. Just like that other one I reviewed, is the heat sinking. Now, if this thing can do 15 watts per channel, that's 30 watts. If it's about 90% efficient, just saying, I don't know what its actual efficiency is. You know, it's still got to dissipate 3 watts or so, and that's a lot for a tiny little chip. And even now, it is getting pretty warm. Any warmer, and I couldn't hold my finger on it. Problem is, they put this socket in here, and that just acts as thermal resistance. It can't dissipate power into the board very efficiently. So if you're assembling this thing, I would nix this socket thing and just solder the chip right onto the board. And I would also epoxy heat sink onto the top of this chip. Then you should be alright. Another problem I have with this is these two capacitors on each side are 220 microfarad. They're put in parallel for output coupling. So you get 440 microfarads of output coupling, and that's just too low. It's going to roll off your bass too early, especially with 4 ohm loads. If you can find capacitors that are fairly narrow, that are 1000 microfarads, they'll probably be taller but narrow like this, I'd put 2000 microfarads in here. Give you a couple thousand microfarads of coupling capacitance. You know, it may not suit the hi-fi guys. They'd say you need more, but you know, I think that's good enough for this. But what they have here is not good enough. Now, if you're not worried, you know, your speakers may not play real deep bass, then you really don't have to monkey with these. Okay, well, that's about it for this thing. I'm going to hook up some speakers and we'll give it a quick listening test. Okay, listening test. Something very wrong. Hear that terrible distortion? It's at very low volume. There is quite a bit of hiss coming through the speakers. Very low volume. It's just that crunchy distortion. Completely horrible. This thing has issues. It's a complete failure. I cannot give this thing any recommendation. If it didn't distort like that and all those other problems, it'd be a nice little amp, but I wouldn't waste my money on this thing. Thanks for watching.